When you buckle your seatbelt and settle into your seat, that aircraft has already been through hundreds of checks. Every bolt inspected. Every system verified. Every warning cleared. The people who made that possible never board the plane. They work in the shadows of the hangar. And without them, nothing leaves the ground. This is the story of the aircraft maintenance engineer. In 1903, when the Wright brothers made their 12-second flight at Kitty Hawk, they were also their own mechanics. They were bicycle repairmen by trade, and they fixed what they built. But as aircraft became more complex, the idea of one person understanding the entire machine became impossible. World War I changed everything. Hundreds of aircraft. Hundreds of engines. Armies needed people who could keep planes in the air, fast. For the first time, aircraft maintenance became a dedicated role. Then came World War II. Tens of thousands of aircraft. Supply chains. Standardized parts. Formal repair manuals. The military didn't just need mechanics, it needed engineers. By the 1950s, the commercial aviation age had arrived. And with it came a simple truth: passengers don't fly on broken planes. Governments began requiring certified professionals, not just skilled workers, but licensed engineers, responsible for declaring an aircraft airworthy. A profession had been born. Today, aircraft maintenance engineering is one of the most regulated professions on the planet. Every commercial aircraft operates on a strict maintenance schedule. Before each flight, a certified engineer performs a walk-around, a physical inspection of the entire aircraft. Tires. Lights. Control surfaces. Engine inlets. Nothing is assumed. Everything is checked. Beyond daily checks, there are 4 major maintenance levels. The A check happens every 400 to 600 flight hours. The B check every few months. The C check, which is the big one, takes the aircraft out of service for weeks. Panels are removed. Systems are opened. Every component is tested. Then there's the D check, also called a heavy maintenance visit. The aircraft is virtually disassembled. Fuselage inspected for microscopic cracks. Avionics replaced. Landing gear overhauled. It can take up to 3 months and cost tens of millions of dollars. At the end of every maintenance task, no matter how small, an engineer signs a release certificate. That signature says, "This aircraft is safe to fly." If they're wrong, the consequences are catastrophic. This is not a job where you get to say, "Probably fine." So how does someone become an aircraft maintenance engineer? The path begins with an approved aviation school, a program recognized by your country's Civil Aviation Authority. In Europe, that means compliance with EASA Part 66 regulations. In the United States, it's the FAA's Airframe and Powerplant certification, known as the ANP license. Training typically takes 2 to 4 years. You study aerodynamics, structural mechanics, hydraulics, electrical systems, avionics, engines. And you spend thousands of hours in workshops, not classrooms. Written exams are just the beginning. Practical assessments are carried out by aviation authority inspectors. The standard is uncompromising. But here's what surprises most people: getting your base license doesn't mean you can work on every aircraft. Each aircraft type, Boeing 737, Airbus A320, Embraer E190, requires a separate type rating, a separate authorization. A separate set of exams. A licensed engineer qualified on the 737 cannot sign off a 320. They are different machines, and the certification system treats them as such. In aviation, being generally qualified is not enough. Aviation is entering its most radical transformation since the jet age. Electric aircraft are already carrying passengers on short routes. Hydrogen-powered engines are being tested. Sustainable fuels are being mandated. The machines are changing, and that means the engineering required to maintain them is changing too. Artificial intelligence is beginning to play a role. Sensors embedded throughout an aircraft now stream data in real time. Algorithms analyze that data to predict failures before they happen. Some systems can flag a potential engine fault 3 flights before it becomes critical. But there is a limit to what automation can do here. When an algorithm recommends a part be replaced, someone must inspect it. Someone must verify it. Someone must sign their name on the release certificate. Because at 35,000 feet, trust isn't a data point. It's a human decision. It always has been. The tools will evolve. The aircraft will evolve. But the profession, the responsibility, the precision, the signature at the bottom of the page, that will always belong to a person. This is the aircraft maintenance engineer. Every profession has a story. Every tool has changed someone's life. We archive both. If this episode opened your eyes to a world you'd never considered, share it with someone who needs to see it. The Profession Archive. New episodes every week.